This is part 2 of the Exam 1 practice test. We're starting with problem number 9. It has this linear regression thing for us. It has a chart of interest rates, and the way it specifies is that we want to call this 1, this is going to be 3, 5, 7, 9, and 11. So let me bring up my calculator here. I'm going to go to Stat, Edit, and I want to type in my x values here, which is my 1, 3, 5, 7, 9, and 11. Okay, then I want to go over here to L2, and I want to type in my interest rates. I'm going to go ahead and type them in like percents rather than converting to decimals, just because it's easier on my eyes. 7.5, 7.75, 8.25, 8.25, 8.25. So I've got my data in there. Now I press the Stat key. I go over to Calc, and I pick this linear regression. You can tell it L1 by clicking second L1, which is on the 1 key, and then second 2 gives you L2, and hit Enter. And it tells us the formula for the line. So the formula it's giving us is, oops, can't see my calculator and my screen. A is 0.1107, so 0.11, oops, (1107x) plus 7.2107. 7.2107. So that's all I need for that part. For part B, it wants me to use my line of best fit to predict the federal prime interest rate on 12/1/06. So 12/1/06 would be 12. So now I just have to put in a 12 here. So y equals 0.1107 times 12 plus 7.2107. I can just start typing at the bottom here. Oops, totally can't type. 07. Fortunately, typing on a real calculator is easier than this. How about plus 7.2107? And we get 8.54%. I don't care how many decimal places you put on an exam if it's reasonable. Okay, next page. Use the graph of f of x to determine the limits below. Okay, so we're just looking at this graph. So the first question says the limit as x approaches -2. So here's -2. From the left we get 3. From the right we get 3. So the limit is fine. It's just 3. This says the limit as x approaches 1, and this little negative means from the left. So as we approach 1 from the left, that means we're coming down like this, towards the 1 from the left, and the limit is approaching this 1 here. This next one is limit as x approaches 1 from the right. That's what the plus mark means. As we go to 1 from the right, this y value is getting close to -1. This one says the limit of f of x as x approaches 1. Approaching from the left, we got 1. Approaching from the right, we got -1. So it does not exist. Alright. Let me shrink this down a little so we can see it. This next one says the limit as I approach 4 from the right. So from the right, as I go towards 4, I'm going up this steep incline. And this dotted line means I have an asymptote, so that means we're going to infinity. Oh, sorry, I was doing 4 from the right. Skipped 1. This one is 4 from the left, judging by the minus sign. As I approach 4 from the left, I'm going up this steep thing. And I'm also going to infinity. And the last one, I think, is approaching 7. So here's the 7. You can see whether I approach from the right or from the left, I'm getting to about 1. So I'm going to write 1. Okay, next page. Calculate the limits. Show some work. Okay. For this first one, the function I'm plugging, well, plugging is the wrong word, but the function I'm taking the limit of is a polynomial. That means I can always plug in. So I just want to plug in my 1. So I've got 1 cubed minus 3 times 1 squared plus 1 minus 5 is equal to 1 minus 3 plus 1 minus 5, which is -6. For this second problem, notice I have a common factor in the top and the bottom, and I've already given it to you in a factored form. The test will be the same way if there's a problem like this. If I try to plug in a 2, I'm going to get 0 over 0, but that doesn't mean the limit doesn't exist. Because, note, t minus 3 times t minus 2 over t minus 2 is equal to t minus 3 as long as t is not equal to 2. This is the limit as t goes to 2, but limits don't care what happens at the point. So I can just cross these out. I can say it's the same as the limit as t goes to 2 of t minus 3. Now I can just plug in my 2, so that's 2 minus 3, which is -1. Easy. Okay. Number 12. G of w is square root of w plus 3. Average rate of change between w equals 4 and w equals 25. So we just want g of, oops, that's not a g. G of 25 minus g of 4 divided by 25 minus 4. So g of 25 is root 25 plus 3. G of 4 is root 4 plus 3. 25 minus 4 is 21. So this gives me 5 plus 3 minus 2 minus 3. Don't forget to distribute the minus to the second guy over 21. This gives me 3 over 21, or I can simplify that to 1/7. If we were to graph the function, which you don't need to do on the exam, it would look something like this. Here would be 4. Somewhere way out here would be 25. And all we are getting is the slope of this secant line. And we've determined that its slope is 1/7. Next page. Find the derivative using the formal definition, that is, as the limit of the difference quotient. On these problems, I will not give partial credit for any other method of finding the derivative. That's for later problems. And I will have one of these three parts exactly on the exam, but only one. Okay, so the definition says f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. So that is the limit as h goes to 0 of x plus h squared minus x squared divided by h. That is the limit as h goes to 0 of x squared plus 2xh plus h squared minus x squared over h. I'm going to go up here, since my teacher didn't leave me enough space to write on the exam. My x squared and my negative x squared are going to cancel, so I get 2xh plus h squared divided by h. I can pop out my h. I get 2x plus h over h. Then my h's cancel. That gives me the limit as h goes to 0 of 2x plus h. And now I'm going to just plug in a 0 for h, and I'm going to get 2x. For square root of x, I want the limit as h goes to 0 of f of x plus h minus f of x divided by h. This is the limit as h goes to 0 of the square root of x plus h minus the square root of x over h. Now look at this limit. I can't plug in 0 for h because I have an h in the denominator. So my trick is I need to multiply the numerator by x plus h, root x plus h plus x. So I'm multiplying by the conjugate. And I need to put that on both the top and bottom so it doesn't change anything. Okay. When I multiply this on the top, this is an a minus b, and this is an a plus b. So I get the limit as h goes to 0 of x plus h minus x over h times this big thing, x plus h, oops, not that big, x plus h plus root x. Alright, going up here, my x's cancel. I get h, limit as h goes to 0 of h over h times this big thing, x plus h plus root x. My h's cancel. I get the limit as h goes to 0 of 1 over root x plus h plus root x. Now I can plug in my h. So I get 1 over root x plus 0 plus root x. And that gives me 1 over 2 root x. This is really the derivative of root x, so that's good. If you get something that isn't the right derivative, there's probably a mistake. Stopping here before I run out of time.